All right, guys, welcome back. Yeah, this is another new session. I'll be talking about manipulating data. All right, so don't forget to join the WhatsApp group. Yeah, you'll see the group link in the description below in the video. All right, and don't forget to share with your friends. Very important. All right, so we're looking at manipulating data, and what we are just doing focus. We are just going to focus more on the aspects of arithmetic operators here. All right, so just like manipulating it one way or the other, and we already know our plus subtraction sign. Oh no, this shouldn't be the subtraction sign. That's an underscore. So this is the subtraction sign, multiplication, division, and remainder. All right, or the modulus sign. Right. So now I want to look more on arithmetic operators right now. So arithmetic operators, like we know, are all this plus and minus stuff, all right? So this equal to sign is like an assignment operator. So it's not the equal to we know in our primary school, in our secondary school, or even in our institution. So this equal to sign is not saying that both sides are equal. It is rather saying we are assigning something to a variable. Okay, we are assigning, we're not equalizing. Okay, just put that at the back of your mind. When we're talking in programming, when we want to talk about real equal, whereby we're saying two things are equivalent, we use this double equal to sign. All right, so that's it. We use this double equal to sign, or we use this three triple equal to sign. Both of them has their own meaning. So I think later in the video, when we'll be talking about logical operators, I will get to explain that aspect. But for now, just focus on this sign, which means assignment operator. So we're assigning something, we're not equalizing it. All right. So let's do small mathematics. All right. Okay. So as usual, I will include stdio.h. Okay. So our int main, sorry, this brackets. Okay, so let's just do a quick maths, just a basic maths. So x, y, I want to declare three variables. So x, y, z, and I want to make x 1. I want to make y 2. I want to make z 3. I'm just doing some quick basic maths now. So I've assigned and I've declared it. So I declared it here. Everything is integer here. And I just assigned 1 to x, assigned 2 to y, assigned 3 to z. You notice I didn't make it in a vertical way. I don't want to take up unnecessary space because I know it will still work this way. All right. So, so let us do some random quick maths. So now I want to let you know something. Since you know that x, in short, let me write printf first before I talk about that. So percent d, new line, and now I want to print x. Okay, return 0. I want to print x, and we know that I've assigned 1 to x. So if I'm printing x, putting a variable of x, I'm expected to see 1 there. Okay, then let me run this now. Let's just see it as a proof. It's loading. Tada. So we've got 1 here. Okay, good. Now I want to show you something. So let me put x here so that to look to make more. Oh, sorry. So to make more sense. So x colon. Good. So let me print this again. So you just see the difference of what I just did here. So x is equal to 1 there. Okay. Or let me use the equal to sign here. Okay, anyhow. Okay, so what I majorly want to do now, I want to let you know that first you notice I declared x as 1. Now, if I choose to declare x again as with another constant, what will print out for me here now will be the new one, not the previous one. So just note that it will take the last value given to x. So you can see now my x is equal to 3, no longer x is equal to 1, even though I've not deleted that x is equal to 1. The same thing will happen even if I put x again equal to something else, so equal to 5. So it will be 5 that will print out for me. So you can see 5 prints out. So it's the last one it will take. So that's what we talk about manipulating data. So we have manipulate this x. So it doesn't just happen to only x, also y and z. All right. So you can just play around that. So let me just do another thing like x plus y. So for example, now something like this. x plus y. We know that x is 1 and we know that y is 2. So it's just like saying, let me comment this. It's just like saying 1 plus 2, which will give us what? 3. So let me print this and let's see the output of this. You can see s is equal to 3. Because we say x plus y, which you know that is 1 plus 2. Okay, because y is 2. So even if I put plus 3 also, it's still plus 3, which is 10 plus 6. All right. I just want to I want to mention something here. Another way of doing the same exact thing. Let me comment this. Another way of doing the same exact thing is whereby you see something like this: x plus equal to y. Now, what this is saying is a shorter way of doing this same thing. All right. So if I print this now, it should give me the same three results regardless. So let's see. You can see it gives us the same three. All right. So what it's saying, it's just saying that this plus equal, just as if we're bringing out x again out and we're plusing it to whatever variable you put inside this place. So this stuff doesn't just happen to x alone. It can happen to y, it can happen to z. Okay, and it doesn't just happen to plus sign. It can also happen to minus signs. Okay, so if I put minus here, what I'm saying, I'm trying to say it is x minus y. Let's run this now. And x minus y should give us minus 1, which is 1 minus 2. So you can see this is minus 1. So just notice all these little things. So they're just some little tweaks in a way. All right, it's nothing really special about it. So don't fear when you see stuff like this. Um, which other feature should I talk about again? Okay, also the same stuff happens to multiplication, no, just so you know. So I can still put multiplication sign here, and this time let me just change this to z. I've been using y since. Let's just change it to z. So that is z. So it's just like saying x times z. Okay, and our x is 1. So 1 times 3 is what? It's still 3. In short, let me change this thing. Let me use y. Y. Okay, so this is like saying then, oh, that means I'm going to put y here also. Sorry, I'm going to put y here also. So this is like saying y times z, and y is 2, z is 3. So 3 times 2 is 6. So I'm expecting this to print out 6 for me. Wait, what just happened? It didn't print out 6 for also. Y is 2. Or is it a bug mistake? Let me see. What is going on now? It's ND. Okay, okay. Look at my printf. I didn't change my printf. Wow. So I just printed this x alone. Okay, so this should be y. Okay, this should. If you notice this before I noticed, that's very good. It means you are really following my classes very well. Okay, that's good. So let's build this again. Hey, yeah, this is what I'm expecting to see. So x is equal to 6. Okay, so that's it. X is equal to 6, which is y times z, which is 2 times 3 is 6. So this is just how to play around this. So let me do one more tricky aspect example. A trickier one. Let me just put it that way. So this one, let me just use z here, and I put multiply by x plus y. Let me just put space. It shouldn't be equal to sign there. Okay. Okay, so something like this. So what do you think the answer, or can you rewrite this? So let me rewrite this. It just means z is equal to z times x plus y. So that's exactly the same thing it means. Then what do you think will be my answer for this? I think we've talked about this in the other lecture. So pause this video and first reason what you think will be the answer to this. Okay, I believe you've paused the video and you've had your own answer at the back of your mind. So now let's see what the answer will give us. Let me not say the answer yet, so let me first shock you in case you are correct or you are wrong. Tada! X is equal to 2. If you got it right, clap for yourself. If you get it wrong, don't worry, I will explain. So now, remember I made mention some time ago in my previous videos about board mass. Okay, so board mass, brackets of division, multiplication. Multiplication came first, which means it's going to be z times x. and our z is 3, and our x is 1. So that is like saying 3 times 1. Okay, so 3 times 1, which is what? 3. Then we have our y. Our y is 2. Okay, so 3 plus 2. What am I saying? I forget again. I'm supposed to put z here. I've- if you got I also if you got that value, you are wrong. Go, you are wrong. So this is it again, Jare. Sorry. 9 should be the answer. In short, why am I still leaving x here? Let me change this thing to z. This minor bug errors. Okay, so yeah, so this is it. Mind you, if you have been following my videos from the start, you would have noticed something that I don't teach perfect videos. Like there are some YouTubers where they want to explain something, they'll make sure they have everything written down, like everything analyzed, so that everything will look perfect and straightforward. But I feel that's not a way to learn. I want you to understand that when you see people that are maybe explaining things like this, it's not say they are perfect. Like, don't think they are perfect or they know everything. They actually make mistakes too. So I want you to understand the way I solve problems and the way I notice things. Okay. So whenever are attempting things like that, you should not think as if it's something as if you are not doing well. You're actually doing well. What you are doing, you are brainstorming and you're trying to find out errors because there will surely be error one way or the other. Okay, so I just want you to understand that part, all right, and how to find errors and how to notice when something is wrong and how to find where the solution might be. All right, so it's very, very necessary to know these skills. All right, not just about perfection. Perfection, nobody's perfect. Just need to have that stuff at the back of your mind. It's still the process of learning. All right. So if you notice that mistake that I made, even before I realize it, it means you are really doing well and you are really sharp and you are noticing all those stuff, which is very, very good. If you don't get it, if you didn't notice also, well, no wala, both of us we are in the same zone now. So let's just go on the same way. All right, so let's print. So our print was what, 9? Was it 9? Let me check again. Okay, z is equal to 9. Okay, let's look at y. It's equal to 9. Okay. Now, when you do something like this, let me do something like this. Then what happens is that it's trying to say x times x plus y. That is what this code now is trying to say in a way. That's why you have to be very careful with dealing with all these minus times and using all this kind of operator stuff. Okay. So if that's why if you know you are a beginner, just stick with this kind of write up and don't just be using this stuff anyhow. All right. So or we can really cause confusion sometimes. Okay, so what this line is saying, this is the interpretation of it. So we say, for example, now we have z here. Z is 3. So let me clean this Z let me clean this Z and replace it with 3. So we have 3 here and our X, we have our X as 1. Then we have our Y as 2. So which is 1 plus 2 in the bracket is what? 3. So 3 times 3 is what? 9. So that's why the answer prints 9 for us. Alright, so just know that stuff. So let me just show you again. Let me do the normal way to look like here. And you see that it still give us the same answer. So let me run this again. Build and run. Oh, sorry, let me remove this board mask. I forgot I even put that kind of stuff inside. Okay, so we have Z9. You can see still the same 9. All right. Now, I want to show you another scenario. Now, whereby if we do something like this, sorry, let me just move only the brackets. Now, something like this now, the answer will be different because of what? Because of the board mass. So that other initial one, the reason it was so because of board mass, because the first one is the bracket, so it's focused on the bracket first. So now there's no brackets here, which means the higher precedence is the multiplication sign, which was the initial stuff I was explaining the other time. So which is we're going to say z times x, and z times x is what? 3 times 1. 3 times 1 is 3. Okay. So that will be the first thing to take. So which is 3 and our y, which is what? 2. So 3 plus y, 5. So this should give me 5. So you can see here, our z is equal to 5. Alright, so that's just how to go about stuff like this. Alright, I believe you understand this aspect very, very well. So let's look at some other concepts. Okay, now talking about unary minus operator. So it's represented by using the minus sign. Okay, so the unary operator is used to change the sign of any positive value to a negative value. Also vice versa. Let's just see what it means with a quick example. Should I erase? Let me not erase all of this. Let me just erase this line. Okay, so we know that now just want to know that x is 1, right? Now if I choose to print, or let's use z since z is already here. I don't want to clean. Okay, so since we have z as 3, so if I print this, we're expected to see 3, like normal now, like right? We're supposed to see 3 here. Good. Now if I come here and I put a negative sign here, it will print -3 for us. So now this negative sign I put here is what we call the unary minus. All right. In as much as I did come here directly in this thing to put a minus. So when you do something like this, it's a unary sign in a way. Let me just say another way of rewriting this. You can rewrite this by saying maybe declaring another thing again. Let me name this one unary as, let me just say uni. Okay, so I use minus z here. Well, it means I have to declare this one also. So let me declare this. I will add it here also, uni. Okay, so uni, I hope it's not a keyword though. So uni, we have, okay, then now I'm assigning minus z to uni. So which means I'm assigning -3 to uni. So that means I'm going to put uni here. So if I print this, this should give me -3. You can see it still the same -3. So it's just another way of writing the same thing. So that's just what unary operator means. The same way, even if I put this minus here, this is -3, then I choose, no, if I print it like this now, z like this, it should still print -3 for us. Just watch. I say it still print -3 for us, right? No problem. So what you can do in this case is that I can choose to then put minus here. To now do minus times minus internally in a way. Okay, we have our minus, let me comment this. We have our normal -3, right? Then I now choose, this z is -3, right? Then I now choose to add another minus again inside the z, which means the other minus will be outside here. Then I'll put this kind of brackets in a way. So to change it to +3, so let's print this. I'm expecting to see 3 here. You can see z is equal to 3. All right, so you can use it to manipulate plus sign or minus sign. So that's what unary operator is just all about. So nothing really special about it. As well, it's still special. Something like this is still special now. So yeah, it's still special. So let's look at the next one: increment sign operators. So talking about pre-increments and post-increments. All right. So let's see what this stuff means. So from this first part, the pre-increments, the operator sign plus plus is come with plus plus, okay, comes before the variable name. All right. While the post increments its own, it comes after the variable name. All right. So the pre-increment, it increments the value of a variable before assigning it to another variable. While the post increments, it assigns the value of the variable to another variable and then increments its value. I understand all these terms like will sound somehow weird to you. So let me just show you a practical example of what that English is trying to say. So once you understand that practical example, when you come back to read this, you will just be like, oh. So that's just it. So let's just do some examples about this aspect. All right, so I want to declare some variables. Let's use just two variables. So say int x, y, and I want x and y to give me if the same value. So let me just say x is equal to y equal to let's just use 5. Can use any number, okay. Okay. Also, what I want to do now, let me declare that variable. I need to declare that variable. Let's just say this one is the name of the variable is results. So results plus x. Just hold on. I will explain what I'm doing. Results um x. Should I use x? Let me use y this time. So y plus. So results. So I have to declare results also. Results. Okay. result. Now I want to print each of them, so I'll do to printf. So print, okay, so I'll say plus x evaluates to this whatever value, okay, and x is now this, that something is there. So new line, let me put on that new line. I want the space to be okay, so comma. So since I have two formal specifier there, and I'm going to put them according to how I want to arrange it. So I will make this one result first, while the second one, the x itself. Okay, so the same thing I've done here is what I want to repeat again. So let me just highlight and copy this because of just to save time and stress. So what's this? Okay, so I'm going to change this one to y plus plus, change this one to y, or change this one to y also. Okay, I think it's okay like this. Now what I want to do here, now we've talked about the pre-increment, and they said this operator comes before the variable. That's this plus plus come before the variable, while the post increment, this one comes after the variable. So this is an example of a pre-increment. Okay, pre-increment operator. Now this is another example of post-increment post-increment operator. Let me just give a space there so they won't jump back together. Okay, so now what all this plus plus sign or whatever, even if it's minus, can be plus plus, can be minus minus. So what they just do is that they add, like this, for example, now this plus plus, they add themselves in one. Like for example, I have 5, if I do plus plus, it can be 6, 7, 8. It's like addition of one. Okay, so that's just it. But now there's a difference in how you place that plus plus. That's just what we're trying to explain here. All right. So I want you to see the effect of it, of you putting it here, and the effect of you putting it here, so you understand their difference. Um, I okay. Let me first explain before I show you the results of the difference. Now, this first one, this pre-increment. Now we have plus plus x. First, we know that x is 5. Okay, we know that x is 5. Then this plus plus x, it has already rushed to add plus 1 for me. That's what it means. Okay, so it has already rushed to add plus 1 for me, which is x. That means anytime, for example, that means when I call plus plus x, that means I'm trying to say it is 6. In my mind, I'm trying to say it is 6. Okay, then our x itself at the end of it will still be the same 6. That's how pre-increment works. Now let me tell you how the post-increment works. Now this one we have plus plus after the variable. So now we know that y is also 5, right? So now when I call y plus plus, I'm not adding it yet. I'm still calling 5. In as much as plus plus is at the front, I'm still calling 5. Like the y is not yet in an hurry to add that one for me. It's until when I now call the y after, then it's giving the final value of that y, which is then 6. That's the difference. So I think this oral explanation I give is enough to understand. So let's just see the output of this. So you can see what I'm saying here now. So this first part, the plus plus x, has already rushed, like it doesn't have chills. It wants to add one immediately. Doesn't want to waste time. So you can see plus plus, it gave us 6. So whenever I'm calling plus plus x, it has already added it straight up for me. And the final value of x at the end of it is still the same 6. Then this y plus plus, if I call y plus plus, it has not added it yet. It's still holding the major y for me, which is 5, which I assigned as 5. It is after it has run its plus plus y, now call the final y of what the final new y would be. That's when it will now give me the addition of that one, which is 6. Okay, but you just know that at the end of it all, their their final value will be 6. Whenever you want to call them singly, it will give you 6. You notice both of them are 6. So the major difference is their starting points. Okay, so this other one, this first one, it will add the 6 either ways, like before and after. While this one we add it after, but before it will still hold the initial value, which is 5. All right, so I think this is enough to explain this. So this doesn't just happen to plus plus, can also be in terms of minus minus. So if I put minus minus here, so quickly think about the answer before I talk about the answer here. So what do you think will be the answer to something like this using the knowledge I've explained in terms of plus plus? Okay, pause the video and think about that. Okay, I believe you've paused the video and you've gotten your own mindset of what you think will be the answer for each of them. So let's see the outputs. So you can see this is the outputs here. Just the same scenario, nothing changed. Since we know that our y is 5 and this one is pre-increment, so it has already rushed to subtract without chills. Okay, so whenever I call minus minus x, it has already subtract from it straight up. So 5 minus 1, 4. Then the final x is still the same 4. Why this other one, y minus minus, it will still hold the initial value of the y. It has not yet done the arithmetic operation yet. Okay. Then when I call the final y, it will now give me the final value of y minus 1. Okay. So plus plus or minus minus is deals with 1. So plus plus is just addition of 1, 1. While the other minus minus is a past subtraction of 1. Okay. So that's just it about that. I believe this is already well explained. All right, so that's just it about the aspect of pre and post operators or increments. So let's quickly look at this part. We are almost done with this lecture. So before, just note this. Let me put it as notes box. Be careful when you compare two values of equality because of truncation of rounding. Okay, some relational expression. We've talked about this thing before in the previous lecture. When it comes to especially integers and floats, there are difference when it comes to calculation. I made mention that integers take only the whole number value. It doesn't take the fraction part or the decimal part. Now, for example, now if you look at this code, I mean not code, if you look at this maths now, like I'm not now, let's look at this in normal mathematics way, not anything related to C. What do you think will be the answer? You say yes, now the answer should be 1 because half plus half is 1, right? Good. Now, but when it comes to C, half is same thing as saying 0.5. Let me just put brackets. Half is same thing as saying 0.5. So if I say 0.5 plus 0.5 is same thing as 1, right? But now, when you are dealing with integers, especially if you specify that it is int you are working with, it means it's not taking the decimal at all. It assumes 0 here and it assumes 0 here. So 0 plus 0, it's not 1. So this is wrong in terms of integer, unless you are declaring it as floats. So if you are declaring it as floats, then this will give you that, yes, you are correct, it is 1. So what I want to give you an assignment of this idea of what I explained now. Do it in your C editor, okay, your code blocks or whatever editor you are using. Practicalize it and test it yourself if it is actually valid. If you do 0.5 plus 0.5, what it will give you in terms of doing it in floats and in terms of doing it with integer, or you can also doing it with double. Okay, well, double will give you some answer as the float anyways. So just know the difference of how the output would be like. All right, so lastly, we are going to look at, okay, also in C, you can convert the data type of a variable expression or constant to a different form by prefixing the cast operator. The general form of cast operator is the data type and the variable. So let's just see this example. That will be the closing example. So let me just quickly erase this. Okay, I won't need this result. All right, so let's just quickly do something very quickly. So I want to print f. Let's say I want to do some kind of like division, for example. So x divided by 2, x divided by y. So let me not do it this way so it won't look okay. Let me first do this way, then I will show you how to do it in another way. Okay. So it's good to do one thing in different ways so that you just know that there's no real fixed way of doing one thing. All right. If you are in ALX, for example, you will notice most of the answers there are usually in a fixed way. But on a real sense, it shouldn't be that way. Like it can be in different formats. There's no one way of doing or solving a particular task. You just need to know that. So probably the reason they have to do it that way is because of the checker, and they are not marking manually. So since they're not marking manually, they want to make everything a fixed way so that the checker will just mark it in a fixed way. So that's just the reason, all right? But in the real sense, the real world, you can't do something in a particular way always. Okay, so let me just quickly do this. Let me okay, let me just leave. I think let me leave this like that. So now notice something here. So what do you think will be the answer here? This is a division sign. I said x divided by y. Okay, I've not even given any, like, see me, I've not given any value for x and y. So x is 2, y is 3. Okay, so 2, I don't want to make it complex. Let me just give something simple like, okay, I want the x self to be above yeah, let the x be above it. Let me just say something like this. Okay, so 7 divided by 5. Okay, it makes more sense. So I want it to be 1 point something. I don't want any 0 point anything here. Well, it doesn't really matter how you choose to. You can still do the 0 point something, but me, I just personally just want to do it this way. Okay. All right. So now look at this, and what do you think will give me? What do you think will be my answer to this? Pause this video and reason this first. Okay. Now I believe you've paused the video and you've tried to reason on your own. Please always pause the video when I tell you to pause the video, because I know some people will not pause their video. Okay. So now let's run this and see the answer. So we'll know if you are correct or you are right. Voila. So if you get it correct, I'm clapping for you. If you don't get it correct, don't worry, you'll get it correct next time. This is not failure, okay? This is just you'll get it soon, soon. The power of yet and great. What's that stuff? Very funny. Okay, so x divided by y. Now it gave us 1. I choose to believe majority will get it. I just choose to believe that like that because I think we even made mention about something like that even in this same video when it comes to dealing with integers and dividing integers. So we know that 7 divided by 5 will give us 1 point something. Okay, 1 point some reminders. Okay, so and we know we are dealing with integer here, and integer don't care about reminders. So it will take only the whole number. So which is 1. That's why our answer there gives us 1. All right. Now what this stuff we're trying to do here in this cast operator. Now this cast operator is a way of manipulating the answer directly from maybe the point f, for example. So it's saying the data type and the variable. So that means this is our variable here, x divided by y. Then I can choose to upgrade the data type to something else. If I put floats here, now what do you think will be my answer to this? Pause the video and reason first. Think of your answer. All right, I believe you've paused the video and you've reasoned, and I just want to be sure that if you have watched my previous videos, you should be able to get this one. If you've not watched my first two, I think my second or third, no, third or fourth video, I made mention about something like this in terms of floats. Okay, in terms, especially in terms of when dealing with two whole numbers, two integers, when using floats in two integers without neither of them having some kind of like decimal or having some kind of floatish features in them. So what it will give me actually is, oh, sorry, I think I didn't do some, since I'm dealing with floats here, that means I have to change this stuff to F, okay? Yeah, I'm going to change that stuff to F to use the float data type. Sorry, okay? So now this will be my answer here. You can see we have 1.400000000. So that's just how it works. You can see it's actually very easy. No long story or long stress there at all. So floats it is with decimals. That's why I can handle this. The same way you can remove that float and I can put double there and to still give the same output. All right. So anyways, so that's how to go about all of this that we've been saying here. All right. I hope you understand this video Thank you very much. Have a lovely day. Bye.